Hi everyone. So now we are in week 14. Um, so week 13, I had you all do 4 tasks. We reviewed how to do converting units. We reviewed with some practice problems. Then we did an airbags article and a video on the mole and what the mole is. So this is all to understand this objective. I understand how to use the mole in a stoichiometry and how stoichiometry applies to everyday life. So today I'm gonna, right now I'm making the video that you're going to watch for this week. I'm gonna post some airbag calculations and molecular mass practice. You will see what that means in a little bit. So I want to go over the article really quickly. So the article that I gave you all to read was the Scientific American publication of how do airbags work. It was published in 1999. But the key thing here, it gives you the chemical reaction that happens. So there's sodium azide that's inside of a canister. And this, once there's a spark triggered, then it decomposes to sodium and nitrogen gas. And the nitrogen gas is the one that fills the, right here, inflates a normal size airbag. It would be 67 liters of nitrogen gas produced from 130 grams of sodium azide. And if you joined us for the Zoom meeting, I had us watch this video, how an airbag works. Takata Recall explained. So it goes into detail. It opens up one of the airbag compartments. It's really, really good for understanding it. So I will be posting this on the description of this. And don't get distracted by the toothbrush. It's nasty. Okay, so I'm going to be putting that link underneath this video. But for now, I want to show you how exactly they knew 130 grams of sodium azide will produce 67 liters of nitrogen gas, which is enough to inflate a normal airbag. So it is very important that they inflate exactly to the amount that will fill the bag. If it inflates too much, the airbag could explode. If it inflates too little, then that means the person might not have the proper protection. So that's what stoichiometry does for us. Stoichiometry helps us calculate if we want a specific outcome, what do we need to start with in a chemical reaction? So that is what I'm going to show you right now so that you can practice on your own. What am I doing? Oh, yeah. So again, the objective, hello? Okay. Again, the objective is objective number 9, and it is about, I understand how to use the mole in stoichiometry and how stoichiometry applies to everyday life. So here, in order to show you stoichiometry, we are doing the chemical reaction that is 2Na3, 2Na and 3 decomposes to produce 2Na plus 3N2. And our article said that 130 grams of sodium azide, NaN3, produces 67 liters of nitrogen gas. So I'm going to show you the calculations exactly on how they got this. So our question might be, how much nitrogen gas would be produced from 130 grams of sodium azide? That might be our question. First thing that you always need to do with a stoichiometry problem is find your given and your goal. So what was given to you? What is the goal? Where do you want to end? So your given, always find the number, how much nitrogen gas would be produced from 130 grams, so 130 G of sodium azide, which is Na. Oops. And I'll leave a little space so I can make a little baby 3. So cute. Okay. And then I can't go back to that one. Okay. Our goal would be our question mark, and it is nitrogen gas. How much nitrogen gas was produced from those 130 grams? Oh. Okay. Perfect. So if you can find your given and your goal, that can be very challenging. But once you identify them, you can use now our stoichiometry graphic. So the stoichiometry graphic is something that I made for us to use. And what this is that it is a way to show you what steps that you need to take. So you always are going to start from somewhere on the left side. So you're always going to start somewhere on the left side and end somewhere on the right side. So you're going to go this direction. You might start with the grams of your given, depending on what you're given, or the liters of given, and end with like the atoms, how many atoms are of the goal. For our problem here, oh wait, I need to clear. For our problem here, our given is 130 grams. Our goal is the amount of nitrogen gas. Oh, we should have specified that the amount of nitrogen gas needs to be in liters. That's my bad. So we're going to start with the grams of your given, and you end with your liters of your goal. Let's take a look at what steps we are going to have to take. So we are going to start at grams of given. And we're going to have to take step 1 to get to those moles of given. And then we're going to go to this side, moles of goal, and we want to end here. So this would be our step 2. Find mole ratios from the balanced equation, and step 3 would be use volume of gas. So if you start here and you want to end there, you're going to have to take 1, 2, 3 steps. So it's a 3-step process. Okay, let's begin. Okay, so which is to calculate the molar mass of given. Then we've got step 2, which was find mole ratios from balanced equation. And step 3, use volume of gas. So if you are confusion about where I'm getting this from, step 1, calculate molar mass of given. That is from our graphic, calculate molar mass of given. Step 2, find mole ratios from balanced equation. And step 3, use volume of gas. So I'm going to be going back and forth from this graphic to our work. Okay, so I'm going to go ahead and make some space real quick. Okay, so I just made a little bit of room for us. I deleted the objective and a little bit of notes that we had. That way I could have room to work. So again, our question, how much nitrogen gas would be produced from 130 grams of sodium azide? And our given, we've got our goal, which is liters, and we've got now our steps. Now let's figure out what we need to do. So for step 1, calculate molar mass of given. So what this means, let's take a look. We need to get this. Something that looks like 1 mole. Let me zoom in. Oh, that zoomed me out. 1 mole given equals a certain amount of grams. So again, a mole is just a quantity. And how it is used in chemistry is that all of your masses here is 1 mole of that element. So for example, titanium, 1 mole of titanium weighs 47.87 grams. Gallium, 1 mole of gallium, so that's 6.02 times 10 to the 23 atoms of gallium. They weigh 69.72 grams. So what we're going to do is find the molar mass of the molecule. So let's do that. So we've got Na and 3. To get the molar mass, first separate it into the atoms. We've got Na and we've got N. So molar mass of sodium by itself would be see, sodium right here, 22.99. 22.9. Oh, that was ugly. 9. And then for nitrogen, 14.01. Now, because of the subscripts, sodium has an imaginary 1, so it stays the same. Because of this subscript, the N we need to multiply times 3. Okay, so if we work this out, we are going to get that 14.01 times 3 would give us 42.03. We add these two together and we get that 65.02 0.02 grams equals 1 mole of NaN3. So molar mass, let's see if we ended up with what we wanted. Calculate molar mass given. 1 mole given equals an amount of grams. We ended up with 1 mole of our given, NaN3, is 65.02 grams. Awesome. So this is first piece of information for step 1. Now step 2, find mole ratios from the balanced equation. So the equation for this chemical reaction is here. 2 sodium azide produces 2 Na plus 3 N2. So let's see from our graphic what is the information that we're going to have to collect. So step 2 is here. Find mole ratios from balanced equation. An amount of moles of given equals the moles of goal. We need to look at our chemical equation. So let's see. Moles of given. Our given is NaN3. Put a baby 3 in a second. Equals the amount of moles of your goal, which is N2. Put little baby numbers. N3, N2. Okay. Now, this is where we need our balanced chemical equation. Our balanced chemical equation says that for every 2 molecules of sodium azide, we're going to produce 3 molecules of N2. So this 2 comes here. So 2 moles of NaN3 produces 3 moles of N2. It's like saying like 2 dozen of this will produce 3 dozen of that. Or like saying that 2 million sodium azide will produce 3 million N2. That's what the mole is. It's just a quantity. And that's step 2. Now step 3, this is the one that's the most straightforward because you just need to memorize a certain thing. Use volume of gas. So whenever you see use volume of gas, all you need to do is 1 mole of gold is 22.4 liters, and that's it. Because every mole of any gas, 1 mole of any gas will take up 22.4 liters if a certain conditions are met. But don't worry about that. So 1 mole. So here this is for our goal N2 equals 22.4 liters. Okay, so first we got given a goal, then we got our steps from our chemical equation. Got our steps from the stoichiometry graphic. And then once we completed our steps, now we need to do the stoichiometry. It looks intimidating, but once you understand it, you're fine. Let me take a second. Okay, so now you're gonna see why it is that we decided to review our converting. So with conversions, we were seeing a number and then a really long fraction with numbers above and below. That's what's coming back. So you're always going to start with your given. Let's do this in pink, just because. So your given is what you start with, 130 grams of Na and 3. That's from here. So that is what we start with. Now we're going to do multiply. We have 3 steps, which means 3 fractions. 1, 2, 3. Okay. So step 1 is going to occupy the first one. Now we're going to use this piece of information that we pulled. Now this many grams is that 1 mole of NaN3. How we decide where to put things, see the gram here and the gram here, we want to cancel those out. So we're going to do the 65.02 grams of NaN3 here, and then the other piece of information will go on top. 1 mole of NaN3. There. That's information from step 1. So again, just to review, our goal is to get rid of things that we don't need. So we don't need the grams of sodium azide anymore. So we're going to cancel that out here. Now we're going to use step 2. And remember, canceling is our idea. 2 moles of sodium azide will produce 3 moles of N2. So here we've got moles of NaN3. So that's what we want. We want moles of NaN3 at the bottom, and then this on top. So it'll be 2 moles. NaN3 will produce 3 moles of N2. Oh, that's a cute 2. And now we're going to move on to the third one. The third one is 1 mole of N2 produces 22.4 liters. So mole of N2 is on top. So we want this at the bottom. 1 mole N2 will give us 22.4 liters of N2. So just to show, let me do this. This grams of NaN3 cancel right here with the grams of NaN3. Mole of NaN3 cancels this mole of NaN3. And then mole of N2 will cancel with mole of N2, leaving us with liters of N2. What was our goal? The amount of N2 in liters. That's how we know we did it right. So let me move this up so that we have more room. Give me 1 second. Okay, so I just moved stuff up that we have more room underneath. So I'm going to rewrite this so it only includes the stuff that wasn't canceled. So it would be 130. Ooh. 130. No, that bothers me. That's thicker. 130. We don't have the G anymore, or the NaN3, times, and then we've got a 1 on top, 65.02 at the bottom, times, on top we've got a 3 over a 2, And then here we've got 22.4 liters of N2 over 1. So when you are putting this into the calculator, how I do it is that I do all the numbers on top first, then divide by the ones at the bottom. So that would mean 130 times 1 times 3 times 22.4. Whatever you get, you then divide by 65.02 and then divide that by 2. So I will show you that in just one second. Okay, I just need to find the calculator in this computer. So 130 times 3 times 22.4 will give us this. Now we divide by 65.02 and then divide that by 2. And we get 67 point, wait, I didn't see, 18 liters of N2. So our question was, how much nitrogen gas will be produced from 130 grams of sodium azide? Through these calculations, we determined that 67.18 liters of N2. And what did our article say? Our article said that a handful, 130 grams of sodium azide, will produce 67 liters of nitrogen gas. Ta-da! So that's how you do it. Now, knowing this, you can now change the amount of sodium azide for the size of the airbag. So some of the airbags, like for the passenger airbag is much bigger. So it's going to need more gas to fill it up. If you have some side airbags, those are going to be smaller. You're going to need less sodium azide because you don't want those to pop and just like explode on someone's face. So that's what your practice will be on. Okay, so again, I'm going to post some practice problems for you to practice stoichiometry with changing the amount of sodium azide and changing the amount of liters of nitrogen gas that would be needed. And I'm also going to post practice on molecular mass. That way you can practice the specific step, which is calculate molar mass of given, or if you're doing this one, calculate molar mass of goal. So remember with stoichiometry, first thing, find your given and goal, find what box you're starting at, then which box you're ending at, follow those steps, and that way you can get that really long thing at the end to get your answer. Okay, good luck.